This is the section 3.7 to 3.8 review. The final problem, number 10. It's a free response and calculators are allowed. So in this problem we are given two functions, f and g, and then we're creating two additional functions by composing. So I'm going to start off just by writing what h is equal to and what k is equal to. H will be f composed with g, and k will be g composed with f. So when I compose f with g, that means I replace the insides of f with an x squared plus 5. So that's an f of an x squared plus 5, which will be a log natural of an x squared plus 5 minus a 21. Which in turn will simplify to the log natural of an x squared minus a 16. Here we want f to go into g, so that means we'll have g of this log natural of x minus 21, which will be this log natural squared plus a 5. So the rest of the problems deal with domains and ranges and derivatives. So the first one says we want to find the domain of h. Now the domain of h is going to inherit the domain of g, which is all real x's, and then we'll have restrictions placed upon it by f. So if we look at the composed function here, for g anything would work, but now the log natural is going to make us restrict this a little bit because we need the inside of that log to be positive. That means we need the x squared to be strictly greater than 16, which in turn means that x needs to be greater than greater than positive 4 or less than negative 4. You could also have written that as the absolute value of x must be larger than 4. The range of h requires you to know what happens when you have a log. Well, logs, if you recall, have vertical asymptotes whenever the inside of the log is getting closer and closer to 0. So the values of x that would create asymptotes on the graph would be positive 4 and negative 4. So we could predict that at positive 4 and at negative 4 we're going to have an asymptote, and we'll get one on each side because we've been squaring the inside. Now because of this, because of the picture, we can see that the range, which is the y coordinates, will be everything less than 0 and everything greater than 0. So the range is y is all real numbers. Or you could go negative infinity to infinity. Part C says we want to find the domain of k. So the domain of k will inherit the domain of f, and then we will add any restrictions that g would impose. So if we look at f, that was my log natural of an x minus 21. Well, that had the domain of x must be bigger than 21 because the inside of a log must remain positive. So squaring it does not restrict it at all, nor does adding 5. So that means the domain of k is still going to be that x minus 21, which is positive, or x is greater than 21, strictly greater. Part D, we want the range of k. So this is where it's important that you understand how graphing works. So if we look at k again, let's recall that it was the log natural of an x minus 21, and then we squared that, and then we added 5. So I'm going to walk through this graphically for you so that you can see where it comes from. If we think about a regular log graph, it has an asymptote at 0. Just the regular log natural of x looks like this. Now when I subtract 21 inside, that's going to move the entire picture over 21 units. So now instead of having my asymptote at 0, it's going to happen at 21, and I'll get this same picture. When I square, then everything that is smaller than 0 will become positive. So when I square it, we'll have this same picture close, except things that were underneath are now going to be above, and everything's going to get just a little bit steeper because all the old y coordinates are getting doubled. or excuse me, multiplied by themselves. Then the last thing we do is we add 5 on the outside. So that's going to take my entire picture and it's going to bump it up 5 units. So we're still having an asymptote and we're bouncing up like this. So we can see that the lowest the y goes is 5, and then we keep climbing for as much as we want. So that means my range in this case is y's are greater than or equal to 5. You could also write that as 5, infinity. Last but not least, we need to find the derivative of h. So I'll write h again since it's out of our sight. We can't see it anymore. We'll have h of x is the log natural of x squared minus 16. So the derivative of that is 1 over the inside times the derivative of the inside. And now we want to evaluate at 5. So if I plug that in, I'll get a 25 minus a 16 times a 10, which simplifies down to 10 over 9, and we're done.